Good morning, everyone. Ayuban, Vanakkam, the two languages spoken in Sri Lanka. Um, uh, People here, I think you're coming off from an enlightening talk from Lee on what AI can do. But there is a lot more to do. I was actually talking with Ranga. There are a few things that I still disagree. I don't think machines are still as good as my colleague Ranga and my colleague Upa on doing this delivery, right, with a smiling face and making sure. Even if they are there, they do far more than an orange juice and a Whopper to get you running, right? They consume a lot more energy. So we are going to see a bunch of different talks on AI in various use case scenarios. We are going to rejig our sequence of talks because of the delayed start. And especially we are going to start off with the talk by Ms. Sara Anika on how you could actually use machine learning for a very important application on predicting coronary heart disease, which many of you recognize as a critical challenge, especially in the South Asian subcontinent. So, Ms. Anika, welcome. You'll have about 10 minutes. And then audience, please hold off on your questions till the end. Could you please share your slides and get started? Good morning. Let's do a take two of the starting of this session. AI and machine learning. Our talks are going to be juxtaposed so that a machine learning algorithm is not able to figure out the configuration of our session. And the first talk is going to be on predicting the smear conversion of pulmonary tuberculosis patients using machine learning, and it's being presented by Lakshan Patirana. And Lakshan will take it over. Again, 10 minutes for your talk and 5 minutes for questions. Please hold off on any questions to the end. Thank you.
Good morning. Good morning, everyone. I am from the Department of Computer Science at the University of Kelaniya, Sri Lanka. Today, I'm here to present you about my research paper, predicting the smear conversion of pulmonary tuberculosis patients using machine learning. So, first of all, I would like to thank my other authors, Dr. Anusha Jaisiri and Dr. Tanuja Tisera, for giving immense support throughout my research. So, let's start. This is the content of my presentation, and let's start from the introduction. Tuberculosis is a disease caused by the bacteria called Mycobacterium tuberculosis. And why this is so harmful? Because according to the World Health Organization reports in 2021, this was 10.6 million people fell ill with TB. And this was recognized as the 13th leading cause of death and the second leading infectious killer after the COVID-19. Then the problem statements. When it comes to the treatment plans, there are two phases, as 2 months of intensive phase and 4 months of continuation phase. For an example, let's say there is a person who has symptoms of TB. And let's say his smear is positive, and we check the smears for detection of TB in his smear. Then now he is smear positive, and the doctors will ask him to take 2 months of treatment, which we call the intensive phase. And after the intensive phase, his smear status will be again rechecked and check whether this smear is converted into smear positive or still remain in the smear converted into smear negative or still remain in the smear positive. In most of the cases, the smear positive converted into smear negative after the 2 months of treatment. But here's the problem comes out. There are some patients who are still remaining in smear positive condition after the intensive phase. So this may be harmful because they can still transmit TB to others. And their treatment plans will also get extended. And it will also affect to their health. And the medical expenses, the resource allocations, these two also will get increased. So our primary objective was to develop a machine learning model to predict those kinds of patients before starting the treatments with related to their initial clinical factors. And by this, the doctors will be able to identify the patients who are at more risk and to identify the patients who need more priority, who need more guidance throughout this research. So to achieve those objectives, I have referred some research papers, and this is the summary of that. In most of the cases, researchers have done their work only for the identification of TB. But in my case, I have moved some steps forward and tried to predict the smear conversion. Mehisha and Mokti have done two statistical approaches to identify the risk factors related to the smear conversion. So with those results, we have developed a methodology, and I'll explain each of these steps in the next few slides. As our first step was to collect our data set. So the Valisara Chest Hospital, which is situated in Ragama, was selected as our study settings. So after receiving the ethical clearance, we have collected our data set. It was mainly in two types. The first one is the patient's clinical data, like the age, gender, education level, civil status, and some symptoms like cough, fever, chest pain, like that. And the initial smear status and the smear status after the intensive phase. And the second data type was patient's chest X-ray images. So the next task was to, the overview of my collected data set was about 185. Initially, 103 were positive and 82 were negative. And after the 2 months of treatment, they were converted into 44 positive and 145 for negative. The next step was to reprocess our data set. So all of the collected data set, all of the collected data were inserted into an Excel sheet, and the chest X-ray images that we have gathered were analyzed with my other authors, and the results were input as a separate input column to this Excel sheet. And the null values were also identified and removed from the dataset. The next one is the data analysis. This is the heat map we have generated to find the correlation between each factors. And initially, there were 14 input variables. And after the analysis, we have identified that 8 of them were most correlated with the smear conversion. They are cough, chest pain, night sweat, loss of weight, smoke, the initial smear status, and the culture results and the chest X-ray results. Then again, we check the output variable, which we call the smear status after the intensive phase. There we have analyzed that it was in the unbalanced state, and we used the SMORT technique, which is an oversampling technique to handle this. So our data set then was increased up to 290 rows of data, and this was our final data set. When it comes to the model development, first, initially, we have divided our data set into two, as 70% for training and 30% for testing. When it comes to the neural network, there are 3 layers, as one input layer having 8 neurons, and one hidden layer with having 6 neurons with the relative activation function, and one output layer having 1 neuron with the sigmoid activation function. And we use the Adam optimizer as the model compiler, and the binary cross entropy as the loss function. The number of epochs we have used were 400. And all of these parameters were identified by doing a hyperparameter tuning. Then we also have done a threefold cross-validation based on our 70% training data set. And these are the accuracy and loss curves we have gathered, we have obtained for that. You can see the accuracy values are getting increasing and the loss values are getting decreasing when increasing the number of epochs. Then we have evaluated our model with the 30% testing data. So we got an accuracy of 90.8%, and you can see the recall, precision, and F1 score values we have obtained. And in figure 15, you can see the accuracy and loss curves we have obtained for our model. And Here, the ROC curve also gave us a 0.91 AUC value, which means a good performance value. In the heat map, it also implies that most of the cases were predicted successfully. So this is a comparison of a model, proposed model with some other research studies. And there also we got a good accuracy value with compared to other existing models. Finally, this is the conclusion. And our proposed model got an accuracy of 90.8%, which suggests that this can be a good way to predict the smear conversion of PTV patients before starting the treatments. And we have analyzed that there were out of 14 input variables, there were 8 variables were most correlated with the smear conversion. And the chest X-ray images were also identified as a good predictive tool for this. So when it comes to the limitations, my data set was about 290 rows of data after the smarting. So this is somewhat limited. And we choose the Valisara Chest Hospital for our data collection process. So there may be some bias condition because we choose only that place. But this can be done in a good advanced way by increasing the number of data sets. And we can use some deep learning algorithms too. And in other research, this can be done in a good way by increasing the number of input variables too. So finally, it comes to the end of my presentation, and I conclude it with the great quote of Thomas Fuller. Health is not valued until the sickness comes. So be safe and protect your life. Thank you.
Thank you very much for your talk. Any questions? I have plenty, so I can do, but I'll give the first opportunity to the audience. It's a very quiet one, unlike me. Okay, I'll get started. So can you please give an idea of why did you choose your network configuration that you did? Was it just an ad hoc choice of, I found this network, I'm going to use this? No. I was asking you about the neural network configuration. Yeah. So why did you choose the neural network configuration that you chose? Why was it your choice of network configuration?
Yeah, basically, since our data set was limited, we have chosen a machine learning model, small neural network. So I used only one hidden layer for that. And the other parameters were also gathered from the initially we set up random parameters for that. And we have done a hyperparameter tuning.
Yeah, did you really need a neural network in this case, or would something like a regression fitting would have been sufficient? Did you do any analysis on this?
Rather than a machine learning model, we haven't done other model.
Okay.
And only the machine learning model we have done.
Sure. And I think the audience would probably like questions to come rather than many questions that I asked. So anyone else for any clarification? Please identify yourself.
Hi, I'm Anraj. So, University of Jaffna. I'm Anraj from University of Jaffna. So I'm curious about your dataset. Like, have you tried any standard dataset is available somewhere? Or the first question. And if not, you might experience lots of, like, you are putting a lot of efforts to collect the datasets, right? So have you planned to publish that dataset in public way, or like somewhere other researchers also can be used?
Yeah, the main problem was when I collected the data set, there were no such data set because I'm considering 2 months of phases. Because there should have the initial clinical factors and the after 2 months output variable. So there were no such data set I have found. And yeah, let's see whether we can publish the data set also.
Thank you.
time for one question from the audience. So I have yet another question. So have you done any, you did show a few parameters, about 6 of them are more important. Did you do a ablation study by eliminating some of this additional information and kind of rank order their importance?
No, up to now we haven't done that, and in future we can do that also.
And I'll probably ask you the last question. So you did show all the images, but if I'm understanding right, the image analysis was done by a human expert, and you just had this binary value 1, 0 that was actually fed into the Excel sheet. How did you validate that the human evaluation of those images were appropriate?
We have done the analysis with chest X-ray physicians, and they can identify whether the smear is having in the chest X-ray images or not. So after analysis, we also count the number of pixels and other stuff also. Then the final result was inserted as like you said, as if the symptoms are there and the TB is positive, we insert it as 1, and if not, 0 as an input variable.
Sure. And again, not just as a suggestion, many doctors don't agree on the same image, right? So there is even variability. So maybe using machine learning for that task could be one more suggestion for you. Thank you very much for taking care of an important problem. Thanks.
Thank you.
I'm going to hand off to my co-chair Ranga for the next paper.
Thank you, Professor. The next presentation will be on illuminating the roads, night to day image translation for we're doing second. First one, I'm sorry. Yes. Yeah. Sorry about that. So we go as per the schedule now. 3-dimensional wireless indoor localization with machine learning algorithms for location-based IoT applications. The authors are MWP Madhuranga, HKIS Lakmal, LP Kalansurya, and it will be presented by Pasan Madhuranga.
Dr. Madhuranga, maybe you can introduce yourself.
So here I'm here to present our recent work titled three-dimensional wireless indoor localization with machine learning algorithm for location-based IoT. I think so. This is my outline. So basically, so what do you mean by the location-based IoT services? Like to get to know the location of the geographical location of a sensor or object. Basically, we refer as the indoor localization. So as you know, the 5G and 6G advancements, the location sensing play a huge role. So location sensing will enable a lot of IoT application I have mentioned here. You know, some application I will show you later. So basically, so whatever the localization method you use in the outdoor environment, like GPS, won't work well in the indoor environment. So that's the basic question we got here. So therefore, there are several techniques need to be investigated to find the location of a object through sensor system in the indoor environment. So here I have shown some couple of diagrams also. You can see, for example, if a human is inside a building, so if you want to locate the exact location, geographical location coordinate of this person or object, so you have to implement such indoor localization system. So moving to the next slide. So what are the issues with the GPS that you already use in the outdoor localization? In the indoor environment, you can't reach the GPS signal. So due to the multipath obstacles, the GPS signal, satellite signal can't reach the indoor environment. In fact, also the GPS techniques are not performed well in the indoor environment. In fact, they have low accuracy. So that's a problem we have with the GPS. So if you think about location-based, indoor location-based actually IoT service, I can list few. Ambient assisted living, your elder people if living inside the houses, so we need to take care of them. We need to know location, etc. So likewise, I have listed many applications that indoor localization can offer. All right, so moving to the next slide. So a little bit theory, basic theories of the indoor localization. So I will take this example, the figure. You can see I have mentioned here the target node and 3 anchor nodes, right? So if you take typical indoor localization system, basically consists with the target node and the anchor nodes. So basically the target node itself a small sensor. We'll discuss the information later. So basically transmit electromagnetic signal to the anchor nodes, right? And I have shown that there's equation RSSI equal, where RSSI means received signal strength indicator. Based on the place you place the target sensor node, this RSS value will be changed. So it's kind of proportional to the distance. You can see in this equation where D and A are the constants. D is the distance, sorry, and the A is constant. So how the RSS value are proportional to the location. So we use this technique in the indoor localization problem. So there are many actually, not the RSSI. There are many like angle of arrival, time difference of arrival. In our case, actually, we have used RSSI. If you compare these distance measurement techniques, each technique having its own advantages and disadvantages. For example, if you take angle arrival, you need another set of antenna arrays. So hardware-wise, the system is very complex. So we have. So if you take RSSI, the hardware is quite simple. You can enable your IoT device to send the RSSI value to the anchor node. So that's why in many works, actually, we saw rather than picking the other distance measurement technique, RSSI has been chosen. Right. So the reason is this: you don't need extra hardware if you implement the sensor nodes. If you transmit the sensor data to the other point, so of course with that you can transmit the RSSI data as well. So the drawbacks of other distance measurement techniques I have mentioned here. Right. So here, so like I told you, the target node sending radio signals. So these are wireless signals, and depend on the indoor localization problem you think you work on, you can select the following wireless technologies: ZigBee, LoRaWAN. For example, if you take LoRaWAN, if you have like very large scale indoor environment, you can go for the LoRa because it's having a large sensing range. So likewise, ZigBee, Wi-Fi is very popular. And if you think of low range localization, you can use the Bluetooth low energy. So this wireless technology also you have advantages and disadvantages. And in fact, it's highly dependent on the indoor localization problem you are going to solve. So basically, in indoor localization, whatever the algorithm you use, fundamentally, you collect the RSSI data or TDO value, whatever the values, distance measurement you take, you fed into the algorithm, and you are going to predict the location. So that's the whole process happen. So these are the challenges. Like, so indo-localization is not a very recent problem. People have introduced several algorithms based on probabilistic and deterministic. For example, Kalman filters, extended Kalman filters. We have kind of simple algorithm also like trilateration, multilateration. The motivation to move to machine learning is like, even though these Kalman filters and other type of algorithm provide good accuracy when it's come to the implementation phase. So these algorithms are sometimes impractical to deploy on real IoT devices. So that's the main motivation behind this. And it's having some low accuracy also. For example, if you take a simple machine learning algorithm, if we come up with a good performance in indo localization, in fact, you can implement this algorithm in IoT edge devices also. So that's the main advantage of using machine learning techniques in the indo localization problem. And the other main issue, problem of this one is like, if you take the RSSI data, RSSI signal, it's highly fluctuation. So very highly fluctuating, and it's we need kind of strong type of filters to smooth or filter this signal. Okay, so basically we formulate our problem statement like this: how to use machine learning technique to improve the accuracy of the indo localization systems. So our main contribution, so we'll apply for a given RSSI data set collected from a building environment, indoor environment. Actually, it's a 3D environment. And we do analysis of the performance of each algorithm, and results are presented. So that's the whole contribution in our work. And also in the literature, we saw several data sets has been proposed. So primarily, most of them are based on the 2D, basically predict the X and Y coordinate. But so we try this time with the 3D localized 3D data. Okay, so this is the process, the methodology. So we get the RSSI data set collected from different location by keeping the target node. And we apply the filters to the data set, and we train machine learning model, and we estimate the location and the model evaluation. So this is the data set we use. This is kind of very popular data set we call a UGI Indoloc data set. You can see in this figure, this is done by the Jamaica University, I guess, yeah, in South Korea. You can see in the figure there are some labels. The building has been labeled. They have collected RSSI data by keeping the target node in each location and collected data using the anchor nodes. So if you can remember the diagram I show you, they have a 3 anchor node, but in this case, we have 525 and 520 anchor nodes. So they have implemented their Android application to collect the data. And you can find the more details about this data set in the given paper. So what we did was like, this building has 5 floors, and each has 3 floors. So their entire floors, we did a modification in the dependent in the categorical column. So we divided it to 15 spaces, and we assigned the IDs from 0 to 50. So that's the modification we did. And the filtering, actually, there are many filters were suggested in the literature for different wireless technology, actually, for different algorithms. It was like moving average filters. There are so many filters, actually. So we noticed that the Gaussian filters giving kind of good performance. Therefore, we thought to go with the Gaussian filters to filter our data set. So actually, to filtering purpose, we use MATLAB. So filtered data, actually, we train using the machine learning. So here, okay, here I'm showing the filtered data of a 2 access point. So these are the basic result. You can see the basic evaluation we have been done already. You can see the algorithm we already trained: logistic Gaussian regression, KNN, distance tree regression, XGBoost. like GBM, support vector classifier, and the Gaussian and naive Bayes. So basically, so there are some related work also that has been contributed machine learning for indoor localization. We select this set of algorithm based on their recommendations. So you can see, for example, XGB and LGB model giving quite good accuracy. You can see their details. So actually, this is an initial study. Our main problem was like, so there are also, we observe some works are there like machine learning applied for the indoor localization problem, but in this case also, we collect the data offline and tested the machine learning model in the computer. But when you come to the real application, so this machine learning model should run on real devices. So that's the problem. For example, if even like GM, for example, XG was given best performance, will it work properly in tiny IoT devices? That's the problem we have. In next phase, actually, we are going to run these algorithms in the real environment. Perhaps we may go with the Raspberry. We check whether this algorithm can run properly in the IoT environment. So that's the problem we are trying to solve. Yeah, that's it. Thank you very much.
Yes, please go ahead.
Good morning, everyone. I'm Angie from University of San Carlos, Philippines. I'm just curious, what is the percentage in your data set is allocated for the training set, and then
yeah, it's 70 and 30.
All right. Thank you.
Thank you for the question. Any other questions?
So one of the key challenges in a lot of these indoor localization aspects is basically some of the signals basically get occluded with an object. So for example, there's a technique that's widely used in many of the malls and other stuff. One of the challenges with these signals is there could just be a metallic shell space or other stuff that basically cause signal loss. One thing that I would like you to try and consider in your work is essentially what happens when your anchor signals are not accessible. And the other aspect to do is while in this data set that you saw, there was almost a uniform placement of all these access points with a good localization in the infrastructure. But many of these facilities are retrofitted with some of these signals as opposed to localized aspects, so you may not have uniform distribution. That's something I'm wondering whether you've had discussions on those lines in your research.
Yeah. So thank you very much for the comment. Actually, yeah, that's correct. Actually, when you operate our anchor nodes at same Wi-Fi, for example, there could be other Wi-Fi devices as well. So sometimes signal can collapse. So yeah, there's impact of that we have to think of.
More importantly, we have
yes.
spots.
Yeah.
And I'm pretty certain there are dead spots in this building, for example,
yes.
Your Wi-Fi space.
Yeah.
I have faced it already.
Yeah. Thank you for the comment.
Thank you for the question and the comment. Any other questions? We can take 2 more questions. Okay, I have one quick question. Now the system depends on the location of the anchor points. So what that means is when you install a new system, the machine learning model has to be relearned. Is that correct?
Yeah, that's correct. So actually, in this one, we just want to do experimental study and to identify which algorithm perform well.
Yes.
So when we deploy the things, well, we have to again to collect our own data set and we have to go as a separate system.
That's right. Yes. Yeah. That means the researchers still have a task even when you deploy.
Exactly. Yeah.
We have our jobs intact. Any other questions? Yeah, then please join me in thanking the presenter. Thank you very much.
So the next talk is going to be Eliminating the Roads Night to Day Image Translation for Improved Visibility at Night. Given the heat outside, I would like the transformation to be the other way around. at least with the temperature day to night. But I'm welcoming our speaker is Suru Shanaka Lakma.
Uh, Good afternoon. My research is also from the domain of generative AI. So in this research, what I'm going to do is I'm going to find a solution to a problem that we face every day, the challenges that we face when we are driving in the dark. So we all know how difficult it is to drive in the night. So what I'm trying to do is I'm trying to build a model, GAN model that is capable of transforming nighttime images into daytime images. So the aim of my research is to transform nighttime images into daytime images with clear and also maintaining the details intact. So basically, this is going to be a cross-domain image translation problem between two domains, day and night. So in this research, first I have to explore what are the options available. So there are different options like supervised image translation models and unsupervised image translation models. So for this initial study, what I tried was I started with the supervised image translation model. So the first challenge that I had to face when starting with supervised image translation model, the finding a proper data set. So when it's come to supervised image translation, we need a pixel to pixel paired images in both domains, the daytime as well as the nighttime. So basically, it's impractical to collect this kind of data set. So we need to come up with some sort of a synthesizing technique to generate this kind of data set. So for that, what I did was I searched for different available image translation models, pre-trained image translation models. So then I choose one of those models to build the data set. So first, I collected a set of images from freely available data sets. These images are in daytime domain. Then using pre-trained models transformed these images into corresponding nighttime images. So for that, basically, when I explore, I found two options. One is the cycle GAN, the other one is the two-day GAN. So when comparing, it was clear that the two-day GAN gave more clear results. So for this case, I choose two-day GAN to synthesize my data set. So once I have my data set, then I try to explore a proper GAN model. So in this case, for the supervised image-to-image translation, pix to pix seems to be best option. So it's showing some pretty good results in the literature. So I try to utilize that for this case. So this is the generator and the discriminator architectures of the GAN model. And the training objective also similar to pix to pix. So we have the when it's come to the overall training objective of the GAN. So in addition to the adversarial loss. So we are trying to minimize the L1 distance between the generated image and the target image. So when it's come to training, so this is the training platform. So the training details. So we use these ADAM optimizer with this learning rate, and this is the batch size, and train for 300 epochs. And for the evaluation also, we used certain parameters like PSNR, SSIM, inception score, and FID. So when we compare, so we saw some significant improvement. So for the comparison, we choose one of the already available night-to-day image translation model, today again. So when we compare, we see that the peaks-to-peaks model that we train showing really good results compared to that. So when we go for the model evaluation also, we can clearly see when it's come to these evaluation metrics, the peaks-to-peaks model is giving some good results compared to the 2-day GAN model. And as future, and also the reviewers of this paper also commented, like I need to explore the unsupervised image-to-image translation models also. So at the moment, we are actively exploring that area also. So here, one of the videos that we created by translating this night-to-day image translation model. And here are a few more images that we synthesized using this model. And yeah, that's the end of my presentation. Thank you.
Sometimes in my class, when students don't ask a question, I give them a quiz. So I hope I don't need to do this distinguished audience. So anyone else? It could be a suggestion, it could be a recommendation. Thank you.
First, thank you very much. Interesting work what you presented. My understanding, the camera matters a lot when you do this data capturing and translation. What sort of a camera, what sort of images that you take it into this one, or is there any kind of an effect did you observe depending on the resolution of the images and the you use the video to transform the data into the night to daytime? Is it that?
No, so actually I synthesized my own data set. So for that, first I collected images, daytime images, real daytime images from publicly available data sets. After that, using a pre-trained machine learning model, I transformed them into nighttime using a pre-trained model. Then I have the paired images using those data set. I trained my peaks-to-peaks model.
So what is the quality of that data set? Is it resolution-wise, at least resolution-wise, was it the...
resolution is fine, but when it's come to the image details, there are some missing points in the details when translating them into nighttime.
Okay.
Nice. You definitely know that I would ask you questions, right? So, I'll just latch on to the question that came in, out there. So you did these basically in the RGB mode.
Yeah, RGB.
For nighttime vision, there are other sensors that are a little better. So for example, some of the event-based sensors are really good.
Yeah.
And then, of course, a lot of the autonomous driving use things like radar and LiDAR type scenarios. So where do you believe that someone is really going to adopt your technology of transforming an RGB from daytime to nighttime to daytime translation as compared to a multimodal fusion with some of these models to do image regeneration? Because if you look at the autonomous driving scenario, which is not assistive driving that you're looking at, they are really very good at least remapping the real scenario using these other sensor modality modes that work much better than the RGB mode. And if you get deeper into the question that was really asked, if it is really the initial image capture in the low light condition really matters, right? So while your scenario may actually work, let's say when you're near Colombo 2, it may not work very well. If you're driving to Peradeniya and on a highway, it may not give you any translation. So I just want you to kind of clarify the intent of your project and kind of comment on how low is low light in your case.
Yeah, at the moment also we are exploring what is the minimum intensity level, lighting intensity level that we can go. In your case also, sir, we can use other sensors to capture more data, but then again, it involves more hardware. We need to integrate more hardware to the automobiles in that case. So we are trying to find a balance between these two. So how we can minimize the number of sensors that we integrate to the automobile, and at the same time, how we can properly map this into the corresponding domain that we are targeting. So we are trying to find the balance between these two.
Thank you. Anyone else? I just have a comment. Just be a little more practical in your work. No one is going to sell an automotive that will just work in Colombo 2 and doesn't work on highway on Peradeniya. And I will also be very unhappy if I actually pay more for your assistive feature, if it works sometimes and if it doesn't work sometimes. So please factor this in future work. Thank you.
Thank you.
Thank you. A couple of announcements before we go to the next session. The session here is broadcasted in the grand ballroom. So be assured that there is more audience down there. Also, the presenters can collect the certificates from the chair after this session. So next presentation is on investigation on cost sensitivity in EEG-based confusion emotion recognition system via ensemble learning. So I guess the presentation is when someone buys an expensive thing, how emotional you get. I get emotional. The authors are Dasuni Ganepala, Intika Karunaratna, MWP Maduranga, and it will be presented by Dasuni Ganepala.
And for the audience, we already had other paper in sequence. So if you're wondering what happened to the paper, was already
yeah. Okay, that's okay. Good afternoon, everybody. So I'm Dasini. I'm presently working at Faculty of Computing General Sejoon Kutalavala Defense University as a lecturer. So my research topic was investigation on cost sensitivity in EEG-based confusion emotion recognition systems via ensemble learning. So this is my agenda. So moving on to my introduction. So my research was, I'm sorry. Yeah. So my research was about studying cost-sensitive machine learning and thereby developing an emotion recognition model. So talking about cost-sensitive machine learning, this is actually a subfield in artificial intelligence. It is not new, it was there, but now it has gained more popularity because we are moving to, the world is moving to develop AI applications which are practical and which is going to be used by the general public. So cost efficiency, how is this coming here is we all know it's a very important topic in the real world, and ignoring these aspects in our models may lead to suboptimal performance and hinder the widespread adoption. So we must explore as AI researchers to implement cost-sensitive approaches to make our systems not only effective, but economically viable as well. So I studied on developing an emotion recognition model that would spot confused students in a classroom. The end users of this emotion recognition system are the educators, like the teachers, the lecturers. So our aim was to develop a confusion emotion recognition system, which is both cost efficient and performance efficient. So that means cost and the performance are well balanced. And our vision of developing such a system was to make the tool affordable to the end users, to the educators, and they can experience the so-called benefits of these AI tools. So before diving further, I would like to give a briefing about what is meant by cost-sensitive artificial intelligence. So cost of a machine learning model can be any of the following. It can be acquiring data for model training, or the computational cost for model training, cost for future processing, or else the misclassification cost. So in my research, I chose the misclassification cost. I wanted to reduce the misclassification cost in the existing confusion emotion recognition models which had been developed. I'm sorry. So here we utilized the data set compiled by Wang et al. And then this is a description of the data set. It had 12,811 EEG recordings in the form of PSD, power spectral density values. And yeah, so I wanted to reduce the misclassification cost, and how I did was it was through ensemble learning. So the ensemble was designed by combining the 7 most frequently used algorithms in previous literature. So 2 ensembles were designed that was in the serial combination and in the parallel combination. So if I see, this is my general methodology. These are the 7 machine learning algorithms which I chose, and the 2 would be serial and the parallel. And talking about the serial ensemble, my design was inspired by Feng Shui, which was a design in 2022. And but the novelty in my design was that I used pairwise disagreement measure rather than the double fault measure to get the disagreement measure. So if I can highlight it. So if you can see here. So first of all, I trained my independent classifiers. And then afterwards, I chose the homogeneous machine learning classifier, which had the highest accuracy. And then I set it as my base model. And then I calculate the pairwise disagreement between the base model and the rest of the classifiers, and the one which had the highest disagreement with the base classifier was combined to form the sub-ensemble. And then I checked the pairwise disagreement measure again, now this time with the sub-ensemble model and the rest of the classifiers, and the one classifier which had the highest pairwise disagreement was combined to form the sub-ensemble 2. So this is the pairwise disagreement matrix. This is how I calculated it, and you can see my homogeneous ensemble model, which I chose it as the base classifier, was random forest. So I combined random forest and KNN to make this sub-ensemble 1. And this is the sub-ensemble 2, 3, and 4 as follows. And then how I trained my sub-ensembles was I trained each sub-ensemble from a subset generated, like a randomly subset generated. And then I trained each of my sub-ensembles. So this was done to increase the ensemble diversity. This is my parallel ensemble. For this, I chose a super learner model. So where I stacked all my machine learning algorithms together, and it had the meta learner, the logistic regression, to do the final evaluation. And this is how I calculated my model performance, precision score, and then the misclassification cost was calculated by the standard cost matrix. And these are my results. So you can see here, the sub-ensemble 2 got the best out from the sub-ensembles created. And this is the summary. You can see how the accuracy increases and the misclassification also decreased. And this is the result from the parallel ensemble. So based on this, I found out that comparing the serial ensemble model and the parallel ensemble model, I found out that the sub-ensemble 2 had the highest precision and the lowest misclassification cost. So because of that, I selected my sub-ensemble 2 as the ensemble model of my research. And then for further evaluation, I compared it with my independent classifiers as well. So I found out that the ensemble model, which I selected, it did not overperform very much, but when it comes to misclassification cost, it was reduced in a very considerable manner. So summarizing what I did so far, my study utilized the concept of cost-sensitive machine learning, and as a result, I developed a heterogeneous ensemble model, which had both serial and parallel, but serial was the best. And the performance and the cost efficiency of the ensemble models, when compared with the independent classifiers, were very much better. And it can be interpreted that the ensemble machine learning models had lower misclassification rates because they combine all the errors from the individual classifiers, so which leads to lowering the false positives and the false negatives, which accounts for the misclassification. And my limitation of the study was that I could not find another data set related to confusion emotion recognition of students. So I could not validate my proposed designs. So my future work would be to compile a data set and then validate my designs afterwards. So these are my references, and thank you so much.
Thank you. Are you open to floor for the audience's questions? Yeah, I have a quick question. How would you incorporate other cost parameters now into the system, like the power, which is a very important parameter in training machine learning systems, and all other things? If you want to do that, I know that this data set does not contain that. Yes.
So then we need to calculate the computation time, like from each of it, like the computation time, and which is called the wall time. Actually, we can calculate which algorithm would give the the lowest wall time, and then we can opt for a machine learning algorithm which gives the lowest wall time.
Yes. Combining them would be very interesting.
Yes, sir. Yes.
So, any other questions from the audience? Yeah, Professor.
Thank you for the talk. So I had a question. So you are proposing ensemble model as a solution, but one thought that came across, by definition, an ensemble is going to do more work than an individual model. Yeah. So I was a little puzzled as to why you call that as cost effective, given that you're actually combining different models together. So I just wanted to kind of understand what aspect of cost effectiveness are you advocating? Is it the training time?
No, actually, it's the misclassification cost, which I'm advocating here. I wanted to reduce the false positive and the false negative. So ensemble learning, it says in theory that ensemble learning can reduce the false positives and the false negatives. So I applied it to my machine learning model, so it became true.
So here you're essentially referring to the accuracy of your classification as opposed to cost, as in like sustainable models that are more computationally less intensive, or things that are more power efficient. So just to kind of understand you're using the term cost to ensure that the cost of misclassification is lower.
Yes, yeah, that's right.
Okay. But I did have a follow-up question on that aspect of the case, right? So, for example, when you talk about emotion recognition in a classroom, as you say, how do you ascribe a cost to a student being confused, right? So sometimes confusion could actually be a good sign of learning rather than. How do you ascribe a cost to those aspects in your model?
So when you think about confusion, you can have positive confusion and then you can have negative confusion. So here in my model, my research, I was more focused on finding out the negative confused students, not the positive confused students. It means when confusion is there for a long time, the student will feel bored and then he will feel frustrated and then ultimately he will give up. So I want to stop that part from my model, from my recognition system.
But do you have an automated classifier for positive and negative emotions or long-term, short-term? So is this done manually in your data set? I'm just trying to make sure.
No, it's actually done by the EEG signals. We capture the EEG signals. So for positive confusion emotion, there is a specific way of the brain waves. And for negative confusion also, there's a specific way. So in this data set, which I use, it's specifically for negative confusion emotion. So then, of course, that's why I went for the misclassification cost from there.
Thank you very much. Any other questions? Maybe we should get all your EEG signals compared to try and figure out what you thought of the time. Thank you very much. So from brain solar cells. So the next talk is going to be on terminal voltage prediction of solar wind hybrid systems with time series decomposition. And the presenter is going to be Mr. Johan Praveen Veersinghe. In fact, it's solar and wind, where near here you have plenty of both, right?
You all are welcome to my presentation. The title of the project is Terminal Voltage Prediction of Solar Wind Hybrid Systems with Time Series Decomposition and Analysis and a Comparative Study. So first of all, I would like to introduce my team and myself, Praveen. And Isru and Samila was involved on this training model and forecasting model, and the last two, Shanta and Rohan, involved in the mechanical development of the system. And the objective is to develop and compare a time series decomposition model for solar and wind voltage system. So here, voltage prediction, as we all know, the voltage prediction is a very important thing, especially on this in the sector of power, because it helps to the planning and the optimization and to maintain the grid stability. And so we have we use this our data set, and we decompose that, and then we build the forecasting model, especially for the wind and solar and wind voltages. And in literature, so I'm not going to discuss this literature in detailed manner. So then these are a lot of techniques available for this time series forecasting approaches, and a lot of machine learning and AI models were developed. And in our time series decomposition technique, we use the STL, so that we have a seasonal component, and we have a trend component, and we have a residual component, so that is the error component. So this is our basic structure, because we developed a mini solar wind system that we plan to install this in, especially in where the power was not there in some areas such as the highways, and there are some coastal areas. There are some requirements are there to install these kind of renewable energy systems. So in our system, we use this Vanuas type wind generator, and then it is actually 100-watt generator, and then we use initially we plan to have a 100-watt solar panel, but so later we go to that 80-watt solar panel, and we have a battery system, and then at the as output we can have a 100-watt load order. Normally we use this system for a light system, lighting the domestic application. So in this project, we have a problem because before we install these systems, we need to have a voltage prediction, because if we install this one and if it is not work, so then we have to remove this again and we have to go for another place. So the voltage prediction is very much important in this case. Therefore we collect some data. So these are the data we collected. So throughout some couple of period. So I think you can just, I think it's clear now that yellow color one is the solar voltage and the blue one is the wind voltage. So this is the actual data. And we use the forecasting model, that is autoregressive forecasting model. In the initially we decompose the actual data that decompose into trend, seasonal and residual. So then you can see the two figures. The first one is this side is the solar, and the other one is for the wind. The first figure shows the initial, this figure, the first line is for the solar actual voltage, and then the trend and the seasonal, and finally the residual. Like the same thing apply for the wind data also. And for the training, we use 70%, and for the training and testing, we use 70 and 30%. And without decomposition, we get this kind of data. Now you can see the left side is the solar and the right side is the wind. So you can see there's a variation, and because there's a mismatch in the two colors. If you apply the STL decomposition, so this is for solar. Now in the first figures shows the trend and seasonal, and this left side one in the bottom, this shows the this residual component, and the recompose after we decompose, we can compose all the three sets again to get the actual information or the actual prediction. And this is for the wind. So there's a huge if we compare with the if we apply the decomposition, we can see some slight variations, but without having the decomposition, there's a huge variation in the wind. And this is the comparatively study. So then without decomposition, the MSE is around 1.9 in solar, and for wind it is 5.9. But if we take the decomposition technique, so we can have the MSE around 0.9 for solar, and for wind around it is around 2.7. So as the conclusion, we develop the comparing time series decomposition. So we can predict the voltage in, we can forecast the wind and the solar, especially as hybrid voltages. And so it is a, without decomposition, so we cannot, it is the research that we use the decomposition technique to get the accurate voltage prediction. And so these findings may help for especially for the energy sector. And I think the end of my presentation. Thank you.
If I do a time series prediction, I'm probably not going to get any questions from the audience. So I'll start with a question and then come to the audience. So Can you comment on, you were doing these solar panel predictions, just the voltage generator. Can you comment on like local variations like shade, cloud cover, or even like a dust storm that may actually have impact on the efficiency of the solar panel? Have you thought about those
actually,
aspects?
so that means you are asking about that whether these environmental problems can affect for the solar generation.
That is, and that's true for wind as well. But I just gave you very specific
that
operational challenges with
yeah,
some of the solar trend predictions.
Yeah, that kind of problem is there. But in our, according to this data set, so we train this data set for a short period of time. So we need more data. Then we need to check whether this environmental effect is actually happened. And then because we plan to install these systems, especially in the coastal area, whether this coastal area and whether their humidity and their temperature and wind problems. So a lot of variations are there. So we need to study more about this system.
Yeah, thank you. So I just wanted to let you know the numbers that you have for prediction are much harder to do when you consider some of these practical challenges over a long period of time. And there is a significant amount of investment on these predictions and some of the large solar farms. And in fact, in those type of scenarios, there may be a lot of counterintuitive things that actually happen in your peak voltages. So for example, immediately after a rain shower, the efficiency goes back because it kind of removes dust and other things on the panel. So the panel efficiency goes up. So those type of correlations will make your work a lot more exciting for you. Thanks. Any other questions? Thank you for proving my prediction is wrong. Thanks.
I just want to clarify. So you measure the voltage before the inverter, right?
Yes.
So the effect of the distribution system, will it affect the measurements that you are taking?
Distribution system is that means
you are connected the final AC after the inverter. The voltage of that side might affect the measurements that you are taking.
Actually, we didn't install an inverter, so that we install the PWM converter is there. So still we didn't apply that for the inverter stage. So still we are getting the voltage in the DC level, and then we are measuring only whether the hybrid system is it work to install in that kind of different applications or not. So in later we can go for an inverter, and then we can check whether it can connect to the grid or not. Whether this we need enough energy to connect it to the grid now.
Okay, so you are measuring these two separately, right? So there's no connection between these two.
Separately means
the
solar and wind.
The measurements from the solar and the wind, you are measuring separately, and
no. There's an interconnected system that solar and wind connected in a same pole.
Yeah.
So one is type wind generator, and the solar panel is installed in the same pole, and then we are getting those voltages at a integrated integrated unit.
So voltage of one system will not affect the other one.
No. That is not affect.
Because they are power electronically connected, right?
Yeah.
Can there be any effect on your measurements? That's what the question.
We are measuring the measurement case. We are measuring those wind and solar separately.
Okay. Thank you.
I think the question is is there a voltage mismatch between the two systems, and when you combine the voltages you have?
When we are combining the voltage and the solar and the wind voltage, so we develop a mechanism. So the maximum voltage is now we have a PWM controller. So PWM controller connects with the maximum voltage for a particular time. If the solar is the maximum, so we can connect the solar when the wind is maximum, so we can connect the wind. So that kind of algorithm is there. Not algorithm, so that we are measuring the power.
Any other questions?
No, not yet. So I think that we need more data, and so it's an ongoing part. So
thank you very much.
Thank you. We apologize from the online presenters for delaying this online presentation, although we wanted to do it as a first presentation. So the next presentation would be early prediction of coronary heart diseases using hybrid medicine learning models. Authors are Seraf Anikap, I hope I am pronouncing the names properly, Mahmudul Islam, and Aditya Palit. It will be presented by Sharaf Anika. Can you hear us? We'll be able to video. Yes, we'll be having the video, but the authors are there online to answer our questions.
Hello, everyone. Good afternoon. Today, I'm going to present my work, Early Prediction of Coronary Heart Disease using Hybrid Machine Learning Models. So the contents of this slide will be the first introduction, then there will be methodology, and after that, experimental results, followed by conclusion and the future work. So what is CHD basically? Coronary arteries work consistently to supply oxygen-rich blood to our hearts, and CHD, or known as coronary heart disease, is the blockage of arteries in the heart due to the plaque buildup. Because of plaque, the arteries limit the blood flow, and when the blood cannot reach the heart, it causes the heart attack and other heart diseases. So the motivation of this work is based on the WHO data published in 2020. CHD is the leading #2 cause of death in Bangladesh, reaching 108,528 deaths, and also the leading cause of death worldwide, causing deaths in millions. So the research question is, how accurately can hybrid machine learning models predict CHD in patients so that the occurrence of this kind of heart diseases can be reduced? And using supervised machine learning algorithms, we are going to develop a hybrid machine learning model that correctly predicts the CHD in patients. Now I'm going to explain the methodology of our work. So we obtain our dataset from an online repository called KIL. The dataset, named South African Heart Dataset, originally contains 462 instances containing 9 independent variables or features, which are systolic blood pressure, cumulative tobacco, bad cholesterol, adiposity, family history, type A behavior, obesity, current alcohol consumption, and age at onset. So the dataset has one dependent variable. The target class contains 2 outcomes, that is 0 and 1. 0, it indicates that the person does not have any CHD, and 1 indicates the person have CHD. Then we are going to go for the pre-processing. So let us first see the diagram. Here is the diagram of the methodology. So data pre-processing, firstly, the dataset was converted from its original .dat format to CSV format for improved manageability. String values within the dataset were then transformed into binary values using the label encoder module from the scikit-learn library. To train and test the models effectively, the dataset was split using the train test split module with 85% allocated for training and 15% for testing, surpassing the conventional 80% train size. Addressing the issue of class imbalance, both oversampling and undersampling techniques were employed in separate experiments. For oversampling, the synthetic minority oversampling technique, or popularly known as SMOT, was utilized, generating 120 synthetic instances with CHD positive labels to balance the training dataset, making a total of 582 instances in the dataset, whereas it had originally 462 instances. Conversely, the edited nearest neighbors, that is known as ANN algorithm, was applied for undersampling, removing 149 observations labeled with CHD positive, CHD negative, that is 0, from the training dataset, making a total of 313 instances from the original 462 instances in the original dataset. So lastly, to mitigate the discrepancy in feature scales, particularly notable between SBP with a mean value of 139.99 and FAMHIST with 0.42, the standard scalar module from the scikit-learn library was employed for data standardization, effectively eliminating the bias caused by scale differences. To better demonstrate the workflow, we can also visit this diagram that I'm showing in the screen. Before this slide, we had included the tools we have used here, like scikit-learn, pandas, numpy, matplotlib, imlearn, seaborn, etc. And these are the train test split that I have already talked about, 85% and 15%. The class imbalance ratio in the training dataset, as you can see in the figure, there is 136 instances with 34.7% positive, and others are, that is 65.3% are negative. Then there is this sampling techniques employed in our work, that is SMOT oversampling and ANN undersampling. And regarding that, we have got these two graphs. In the left side, we have got the SMOT oversampling technique. After applying that, we have got a 50-50 situation. And ANN undersampling, we got a 56% positive one and 44% negative situation. As you can see from the figure, the comparison between the sampling techniques, there is the original data set is shown in the figure, the diagram, without any sampling. And after using oversampling, we have got this type of data. And after using undersampling, we have got this type of data. Okay. And the mean value from the original data set were like this, whereas FAMHIST is 4.42, and here the FAMHIST is definitely has decreased. Then we are going to switch to the experimental results. So we have applied a number of machine learning models like k-nearest neighbor, support vector meshing, logistic regression, Gaussian naive Bayes, AdaBoost, and XGBoost. So after the initial accuracy and sensitivity of individual models without using any sampling techniques are shown in the list without using the SMOT. So due to the imbalanced data set, we have addressed with the oversampling and undersampling technique. The subsequent phase of the analysis was hyperparameter optimization that we have come next. The following results were yielded like this in the figure, as you can see. This is the previous research with the same data set, and the sensitivity and specificity along with the accuracy, as you can see, using the naive Bayes model. And our initial list of model, these were the initial list of model. Our plan of action was to find the well-performing individual models and eliminating the rest. Then the perform hyperparameter optimization that I'm going to talk now on the remaining models. After that, we are going to create an ensemble hybrid models from the above individual models. So these were the performance I was talking about. After the hyperparameter optimization, we have got this data, whereas you can see the sensitivity between KNN XGBoost and support vector machine has increased susceptibly from our initial data set performance, and the accuracy has also been increased in the support vector machine and the AdaBoost and naive Bayes model. The ensemble techniques for hybrid models, bagging classifier and the voting classifier, that what we have employed here. As a result of the hyperparameter optimization, submodels did better in the accuracy and sensitivity to create hybrid models using well-performing individual models. The poor-performing algorithms were eliminated. That's what we have seen in the steps. For each model, randomized search and grid search algorithm has been applied to find the best combination of hyperparameters. It should be emphasized that the logistic regression did not perform any better when using the best combinations found by the search algorithms than when default hyperparameters were used. So here I can talk about some of the hyperparameters that we have used in our models. Like in AdaBoost, the learning rate was 0.1, then estimator was 50, naive Bayes, the smoothing was 0.123284. The XG AdaBoost, there was an estimator 10, max step 1, learning rate was 0.01. KNN leaf size was 1, neighbors 30, weights was distance. SVC, we have C equals to 1.85, gamma was 0.001197. Logistic regression, the penalty was none, and the solver equals to Newton hash CG. So to construct the hybrid model, the ensemble techniques that we have already seen, the bagging classifier and voting classifier has been applied from the scikit library. With the bagging classifier, the bagging technique to each individual model has been applied, resembling the creation of a hybrid model like random forest, which combines multiple decision trees. Additionally, utilizing the voting classifier, two distinct models have been to form a hybrid model, ensuring superior performance compared to the individual models. Experiments with both soft voting and hard voting methods has been conducted to determine the optimal approach, as you can see in the figure. So this is our top performing bagged model. This is the voting classifier models, that is the model 1 and the model 2 with voting hard and voting soft. And this is the experiment with a different configuration. After applying the ensemble techniques, we have also applied different train test split to see how our model works. And with 70% to 30% train test split with the sampling method SMOT, the model XGBoost performed quite well with its accuracy and the sensitivity rate. And with the train test split with 85% and 15% sampling method ENN application, the model AdaBoost performed in a very different way from the SMOT to ENN. Both are applied here. And using the SMOT, we have achieved 79% sensitivity with a 73% accuracy, whereas in AdaBoost, the sensitivity was 92% and the accuracy was 70%. So the conclusion is to find out the best model classification report and see the confusion matrix as well. So as you can see in this figure, that after conducting the experiments with the 85-15 and 70-30 train split, the purpose of this experiment was to evaluate the performance of models under this particular split. So among all the models in our list, the hyperparameter optimized XGBoost identified as the best performer if we use the 70-30 and the AdaBoost performed the best using the 85-15 as we said. So based on the outcomes of our extensive experimentation, 3 models has been identified that emerge as the top performers, with the sensitivity score serving as the primary performance metric. These models have been ranked from 1 to 3, the first in rank being the proposed model. As we can see from the figure, that is our proposed model. And before that, it was our previous research proposed model. Then there is our model 2 and the model 3. So in The objective of our work is to achieve both excellence in both accuracy and the specificity score. However, it is important to note that in terms of specificity score, the proposed model is marginally lower than the naive Bayes model. Moreover, the primary focus throughout the research process was on achieving a higher sensitivity score rather than maximizing specificity. So this decision was based on the nature of the research question and the goal of the analysis, hence the superior performance of this proposed model in accuracy and sensitivity score compensates for any marginal decrease in the specificity score. So it proves that it is evident that the proposed model that we have discussed so far has excelled the existing work in both terms of accuracy and the sensitivity. And we can also see the classification report. As you can see, with 88% proposed model, we have achieved 88% accuracy, and there is 92%, and there is the model 3 got the 92%. Confusion metrics are given here, the proposed model for model 2 and the model 3 as well. Now, we have come to the concluding part. In the future work part, the high specificity score that we have, I have already mentioned that we need to work on that as well. Synthetic data generation, explore the possibilities of better model performance through synthetic data generation techniques, definitely. And create these design smartphone applications, like the user should be able to enter all the elements that has regarded as features in here, those 9 features in their app, and there should be some output like warning you are in risk of CHD, following are the main causes, the tobacco and LDL. So this would definitely give this work a very good output based application, and the users can be benefited from this work and prevent and be cautious about their heart health. So that will be all for today from me. And if there is any question, I will be happy to answer. Thank you for your time.
Thank you very much. Thank you for sending us the video. I open the floor for the questions from the audience. A quick question from my end. Have you tested your proposed systems with any other data set than what you have presented?
Hello, can you hear me?
Yes, we can hear you loud and clear.
Hi. Okay. So no, we did not have that time constraint that we could have compared the data set that we have collected with another data set. We could not compare that, but we are going to work on that as our future work part. Thank you.
Thank you. Thank you very much. Any other questions from the audience? Yes, Professor.
Thank you for your talk. Looking at some of the accuracy numbers, did you try employing any of the deep neural network models? Because I just saw you use more of the traditional machine learning models and out there. Can you comment on whether you tried them and you found them not as effective, or you just didn't try them?
Thank you for your question. That is actually in our future work part. Due to the time constraint, we could not actually go to the deep neural network part application, but we are considering to expand the data set that we are going to work on a more data set, accumulating them, and then we are going to work on the deep neural part to check whether they are going to give us better accuracy and the sensitivity and all that. Thank you.
And I'm going to ask you a question that may sound cynical, but it is not. There was a keynote talk this morning on AI and trying to make sure that the AI models are reachable, accessible, what they can do, right? So my question is, you had a very nice concluding slide, keep away from tobacco, just look for cholesterol. So do we really need these predictive models, or just a simple common sense will be sufficient in these type of scenarios?
I'm sorry, I think I missed the keynote talk, but I can tell from my knowledge about understanding this topic that definitely the common sense works better, but most of the time, because of stress and other things, we actually try to accumulate some bad habits in our life, like taking tobacco and taking the consumption of alcohol, etc. So if we can check the level that how much we have taken, whether it is hampering our health in that way, then we can stop or control that level of consumption. And if we can accumulate an app like this, then we will be more aware of what is happening with our heart health.
Thank you very much. And as I said, I was being cynical in my question, not necessarily doubting the value of your research. So thank you for what you're doing. And thanks for being patiently waiting for us moving you around. Appreciate that. That brings us close enough to your lunch. But before that, we are going to hear about enhancing large language models with custom data, leveraging of document indexing for contextual embeddings by Sudham Rohanadira.
Good afternoon to all of you. I'm Sudham Rohanadira. I'm a research assistant and a master's student at University of Colombo School of Computing. First and foremost, I would like to express my sincere gratitude to the APAN56 organizing committee for providing me this opportunity. The title of this presentation is Enhancing Large Language Models with Custom Data, Leveraging Document Indexing with Contextual Embeddings. This is a brief presentation based on an ongoing research and development project to develop an intelligent application for education by University of Colombo School of Computing, or UCSC. As you all know, large language models such as ChatGPT has revolutionized our day-to-day tasks. But however, these LLM sometimes generates wrong responses and they lack contextual knowledge on certain subjects, like the BIT degree program of UCSC, which stands for the Bachelor of Information Technology. As example, I asked what is BIT from ChatGPT. So this is the answer I got. Here's another example from OpenAI Playground. It says BIT stands for binary digit, and so this answer is related to computer science, which is not the answer we want. And this is how our development responded to the same question. It says BIT stands for Bachelor of Information Technology and is a 3-year degree program offered by the University of Colombo School of Computing in Sri Lanka. It is designed to provide students with knowledge and skills necessary to become successful IT professionals. Quite good answer. So how can we solve this problem? We propose to inject the context along with the prompt to the LLM. But injecting all the context you have is not efficient. Example, I think there are hundreds of PDF documents to inject. This will quickly exhaust the limitations of the LLMs, and also it will acquire an unnecessary cost, which is a waste of money. There are two key concepts we utilized in our approach. They are embeddings and retrieval augmented generation. Embeddings is a numerical representation of semantic relationships between words in a text. Embedding is a vector list of floating point numbers. The distance between two vectors measures their relatedness. And most importantly, using embeddings, we can extract the relevant contextual information which is related to the question we want to ask. Also, the most important concept in our approach is retrieval augmented generation. It is a paradigm for augmenting LLM with custom data. We utilize two fundamental tools in our development, Llama Index and two OpenAI models. Llama Index is a novel open source document indexing framework written in Python language. It allows to seamless integration of custom knowledge sources with LLMs and is based on RAG or retrieval augmented generation paradigm. And we used OpenAI models, text embedding ADA002 for embedding generation and GPT-4 for response generation. We created 4 different knowledge sources as document indexes using Llama Index framework. They are from BIT Student Handbook, BIT website, and BIT FAQ. Also, we created an integrated index by concatenating all of these datasets I mentioned above. For BIT handbook, we broke down the text data derived from it according to in a logical order according to the headings and subheadings. For BIT website, we scraped the text from the website and pre-processed it. Moving to the methodology, first we performed an automated testing using BIT FAQ set as our test data set. And we did a qualitative analysis on the results from BIT handbook index, BIT website index, and the integrated index. Moving to the methodology of the analysis, first we randomly selected 30 questions or prompts in the context of large language models from the test results. And then we analyzed the contextual accuracy of the generated answers, labeling them as correct or incorrect. Finally, we analyzed them when you analyze the quality of the answers with 3 labels, too low descriptive, moderately descriptive, and too much descriptive. Too low descriptive means the details are not enough. Moderately descriptive means the answer is good. Too much descriptive means the answer is too lengthy or there are too many details. Moving to the findings of the analysis, integrated document index gave the best performance. There are 93.3% of correct responses, 6.7% of incorrect responses. Within the correct responses of the integrated index, there are 14.3% of too low descriptive responses, 71.4% of moderately descriptive responses, 14.3% of too much descriptive responses. Moving to the website document index, there are 65.5% of correct responses, 34.5% of incorrect responses. Among the correct responses in the website document index, there are 15.8% of too low descriptive, 52.6% of moderately descriptive, 36.1% of too much descriptive responses. Moving to the last index we analyzed, the handbook document index, there are 65.5% of correct responses and 34.5% of incorrect responses. Within the correct responses in the handbook document index, 10.5% of too low descriptive, 68.4% of moderately descriptive, and 21.1% of too much descriptive responses. In conclusion, our study reinforces the idea that combining various knowledge sources yields improved results in augmented retrieval generation. With tools like Llama Index and the power of contextual embeddings, we are edging to closer enhancing capabilities of large language models. it's important to acknowledge the limitations of this study. This is a qualitative analysis conducted by human, so which introduce a potential bias. Furthermore, factors affecting human performance, such as stress, could have influenced the analysis. With that note, that's the end of the presentation. If you have any questions, I'm happy to answer. Yes, correct. Yes, of course.
I'm Mayuri from University of Ruhuna as assistant librarian. I have a question. You have explained about the abbreviations as the text. That means bit means abbreviation.
Yes.
That means you use abbreviations for the sample text or all the context.
No. What's the abbreviation you mentioned? Is it BIT?
Yes,
No.
BIT.
BIT is the degree program, Bachelor of Information Technology.
No.
Yes. So that is the area that we created a chat engine, which use the knowledge from all these BIT student handbook, the BIT website, and the FAQ related to BIT degree program.
That means you address only for the, not only for the abbreviations. That means you have address for all the type of text.
Yes, all the knowledge we can get
you
from.
You have given only BIT.
Yes.
That's why I'm asking. Yes. Okay. Thank you.
Thank you very much for that question. Only as an example, you showed that.
Yes,
right?
yes.
So, any other questions from the audience? Yes.
If we go to the GDP, then it can violate the entire community. Then whoever want to find what is VIT, then you can put what you want. Is that a way we can do with
the developers has to be responsible in that case, because we are using the API, so we are making a custom app. So entire control in that app is in our hand. ChatGPT is something different.
Okay, you are not going to inject into that, no?
We are injecting using the API. So API.
Oh.
So we have the control on that.
Oh.
That's fine.
Many questions because it is a ChatGPT, right? Yes. So whatever you inject does not stay with ChatGPT.
No, that does not.
That's yes. Any other questions? Yes. A little bit louder. I think the microphone is.
Hello. So you mentioned about the limitation of this research is that human has to label the response, and human can be biased. So in a way, it might create an echo chamber for the AI model. Am I right to say that? So the reinforcement on the response might be going to a different direction other than the correct response, right?
Can you? I didn't got your question.
So you were saying that the limitation is that human has to label the response, like you have to label it as too much information, too little information. So if you say like human labeling can be biased, will it be possible that the response can be less accurate if we reinforce this response? You label it as too little information, and it reinforces the response, so it becomes like less accurate.
Yes. Actually, this labeling is for just to analyze the results from what we get from the API. We are not making a model from that.
Oh, okay. Thank you so much.
So there's no reinforcement learning involved.
No.
Do not affect the model.
No need for reinforcement learning as we are learning using GPT models.
That's right. Yes. So any other questions? So many questions. Yeah. I'm just wondering what's the maximum.
Yes. Maximum length is the limitation provided by the LLM. I think for this GPT-4, it is about 32,000 tokens. But we can control. There's a parameter that we have to pass in the llama index, so we can control the length of the chunk. Or we can manually create the chunks we want and use that as the input for llama index.
Just a clarification that you are the limit is the number of characters, so you could actually do an operation model to tune whatever the input was smaller. So the context length is really there.
Then she's showing the author.
Thank you.
Thanks, everyone. I think the last talk got us to a desired state where all of you opened up. Maybe you wanted to go for lunch and you were worried I was going to ask more questions, so I didn't. Thanks to all the authors. If I may request all the authors who are present here to walk up here so that we could give you your certificates. And if I can just ask the audience to stay a few minutes when we hand out the certificates.
And a nice key tag from Peradini University.
I'll quickly call out the presenters' names. I'll quickly call out the names of the presenters. Hasan Maduranga.
If there is someone on behalf of these authors, you can please come forward.
Yeah, Isuru Shanika Lakman. Ravindu Lakshan Patirana. Please come forward. Dasani Ganepola. Ravindu Lakshan Patirana. Johan Praveen Veerasinghe. Do we have Isuru Shanika Lakman? Sarah Panika, she presented online. Sudam Rohanadeer.
Okay, ladies and gentlemen, we have reached the conclusion of the first session of the conference. I would like to extend our gratitude to the presenters, session chairs, and the audience for contributing to such an engaging session. At this moment, it is my privilege to invite the chairperson of APAN56 conference, Dr. Damayanti Herath, to present a token of appreciation to our esteemed session chairs, Professor Vijay Krishnan Narayanan and Dr. Anga Rodrigo. Please come to the stage, sir.